One of the interesting things about technology is it gives us new ideas, new tools, thinking tools with which to approach old problems. Problems in history, problems in language, problems in the mind, problems in understanding culture and how we got to where we are. Obviously, there's this idea of software, this ephemeral notion. It's not really a machine. It's the settings of the machine. It's the instructions. It's something a little more subtle than the machine itself. But as we know with computers, with apps, with everything you download on the internet, software is, in some sense, the more important part. So I want to use software as an idea of thinking about history and how our brain might work and why it was difficult to understand both of these things before we had an understanding of software. Well, as you know, we write computer codes that talk to the chip. But the interesting thing is, one of the first useful things you can do when talking to the chip is write a new language. So you're given a base language, essentially the mother tongue of the computer chip. This is often called machine code. Machine code's not easy to work with. So the first thing you do is you simulate another machine. You create software in machine code that makes your chip act like a different chip. A chip that's actually easier to use than one you might have. So an example of that might be using machine code, and then the next layer up is called assembly, to create the C computer language. And maybe people have heard of the C language. Very, very powerful and popular. But once you get to C, you can do it again. You can create another language on top of that, built out of these tools that are easier to use than the machine language. And you can create another layer, like Python, for example. You can build it out of C. But once you've got Python built up, you can actually use Python itself to talk to the chip. You can bootstrap it. And now you're at the point where you don't need C at all. You can kind of forget all about it. This idea of bootstrapping, of building a set of tools and then building tools on top of that and maybe tools on top of that, and then throwing away the scaffolding. I think this is a metaphor we need to use when we approach things like history. How did we get to the modern world? Well, how did we build Western civilization? How did we get the Roman Empire? We think of the modern world as sort of being built on the past, but the past was built on its past, and it was built on its past. Sort of like when you go and you excavate an ancient city, you find there's another city right underneath it. And sometimes a city underneath that one. I think that's what's happened throughout history many times, where we no longer have the old languages, the human languages. They're long forgotten. We don't have the civilizations that built the civilizations that led to the one that we're in now. And this is why it's so difficult to try to understand the past. I think it's also why it's so difficult to understand the mind. We try to understand language, we try to understand words, culture, human behavior. But that was built, again, by civilizations that don't exist anymore. And their parent and grandparent civilizations also don't exist. And all of the history is sort of buried under the sands of time. And so I think we need to look at this idea of bootstrapping and effectively try to decompile, to reverse engineer the source code. I'm hopeful that AI is going to help us do that. Go back to some ancient manuscripts, look at hieroglyphs, go look at the ancient structures that we scan with LiDAR and dig out of the sand at some of these historical sites that are relatively recent discoveries. And then maybe we can find our original source code. And I think that's going to help us debug humanity, get to the next generation of software that's either going to heal us and the pains we see in the modern world, and also help us get to the next level, whether that's in the stars or a spiritual journey into inner space.